In bacteria, there are two types of ways that transcription can be terminated. One is Rho-dependent, and that involves use of a rut site, which is part of the transcription region, the transcribed region on the DNA, and that's transcribed into the RNA. At this site, the Rho protein binds and begins to make its way up towards the RNA polymerase. At some point, a hairpin forms. This is part of the transcription mechanism and is not distinct necessarily from Rho-independent termination, in which a hairpin also forms and is actually more instrumental in the termination process. But this is one point of confusion in the book where if you're trying to distinguish between Rho-dependent and Rho-independent termination, they both form hairpins, but in one case the hairpin is of a distinctive type. In this case, the book doesn't say anything specific about the type of hairpin that's involved here. But the important thing about Rho-dependent termination is that it involves a rut site to which the Rho protein binds. The Rho makes its way, moves up towards the polymerase, and when it reaches it, it helps release the polymerase from the DNA. And so that's how Rho-dependent terminators work. For Rho-independent terminators, there's actually an inverted repeat that is encoded into the transcribed region, such that when I would imagine that this is probably a larger hairpin region, and it's so big that it actually destabilizes in combination with this this polyadenine region, which creates a region that's has weaker bonds between the RNA and DNA. So recall that CG bonds have 3 hydrogen bonds, whereas AU or AT pairings have 2 hydrogen bonds. And so if you have a region that's rich in A's or T's, or in this case A's and U's, you're going to have a weaker interaction between, in this case, RNA and DNA than if you had a more even distribution of nucleotides. And so this helps, in combination with the hairpin, helps destabilize the RNA-DNA complex and allows the RNA to be released.